Whenever you put on a VR headset and get lost in a new world, have you ever stopped to think, how in the world did they build all of this? I mean, everything, from that coffee cup on the table to a huge sprawling alien city, every single object has to start somewhere. Well, today, we're going to pull back that curtain. We're going to see how these amazing virtual worlds are built, literally, from the ground up. So, let's get right into it.
All right, so here's the journey we're going to take. We'll walk through the 5 big stages of creation. First, we'll look at the blueprint, the basic plan for any object. Then, we'll get our hands dirty as digital sculptors to give it a shape. After that, we'll act as painters to make it look real, then become puppet masters to make it move, and finally, we'll see how the virtual camera lets us see it all.
So, first things first, the blueprint. Look, before you can build anything, I don't care if it's a house or a virtual spaceship, you need a plan. In virtual reality, we call this plan geometric modeling. It's really the fundamental language we use to describe any object to the computer.
So what exactly is geometric modeling? Well, at its core, it's just the process of defining the 3D shape, the geometry, of every single thing you're going to see in that virtual world. You can almost think of it like the object's DNA. It has all the essential information that makes the object what it is.
So what's actually in this digital blueprint? Well, it tells the VR system 3 absolutely critical things. First, its basic shape and structure. Are we talking about a cube, a car, or a complex character? Second, it describes its surface. Is it smooth like glass or rough like stone? And finally, it nails down its exact position and orientation in the virtual space.
Okay, so we've got our blueprint. Now for the fun part, actually creating the shape. This is where we put on our artist hats and become digital sculptors. Our clay is virtual, and let me tell you, our tools are incredibly powerful software.
Probably the most common way to create these shapes is with something called a toolkit editor. If you've ever heard of programs like Blender or Unity or Maya, well, this is what they're for. They're basically the digital artist studio for building 3D models completely from scratch.
The whole process is actually a lot like playing with digital Legos. You start with really simple, primitive shapes, a cube here, a sphere there. Then you can stretch them, squash them, rotate them. By just combining these simple forms, you can build up incredibly complex models. Think a car or a building. And then you can zoom in and use finer tools to add all the little details.
Now, the biggest advantage of doing it this way? You get total, absolute creative freedom. You have full control over every single point, every single surface of your design. This makes it the perfect method for creating animated characters, assets for video games, or brand new concept designs that only exist in your imagination.
But what if you want to bring a real-world object into your virtual world? Well, you don't always have to build it from scratch. Instead, you can actually capture it using a 3D scanner. It's kind of like a camera, but one that sees in 3 dimensions.
And the technology behind this is just fascinating. So the scanner shoots out patterns of light or lasers onto an object. Then a camera records how that light gets distorted when it bounces off the surface. All this data creates what we call a point cloud. We're talking millions of individual data points floating in 3D space. Then, cool software comes in and basically connects all those dots to create a super detailed and accurate 3D version of the real object.
So this slide gives us a great overview of the different tools in the toolbox for creating 3D shapes. We've talked about the 2 most common, the total manual control you get with a toolkit editor and capturing the real world with a 3D scanner. But as you can see, there are other specialized methods too, like using super precise CAD models from engineering, or even just downloading ready-made objects from online databases. The main takeaway here is that there's a different tool for every job, and each one has its own special strengths.
Okay, so we have our 3D sculpture, but right now it's pretty boring, just a blank gray model. To really bring it to life, we need to add the paint. And in VR, paint means 2 things, lighting and textures. This is what gives an object its realism, its color, and its character.
I'm telling you, lighting is what sells the reality of a scene. This table here shows the artist's lighting kit. You've got everything. There's ambient light, which just gives a general brightness everywhere. Then there's directional light, which acts like a powerful sun. You can place point lights like little virtual light bulbs, use a spotlight just like a flashlight to guide the viewer's eye, or create these beautiful, soft shadows with an area light, which mimics light coming from a window. Mixing these together is how you create a real mood and atmosphere.
So lighting is half the battle. The other half is texture. Now, instead of modeling every single tiny brick in a wall, which would be crazy difficult and take forever to render, we use this amazing trick called texture mapping. The easiest way to think about it is like taking a 2D image, like a sticker, and just wrapping it around your 3D model to give it a detailed surface.
So how does that even work? Well, first, you get your 2D picture. Let's say it's a photo of a brick pattern. Then you have to tell the computer how to wrap that flat picture around your 3D shape. This is done by assigning something called UV coordinates. A good way to think of this is like creating a flat sewing pattern for a 3D shirt. The computer uses that pattern to wrap the 2D image perfectly onto the surface. It's so clever.
All right, our object now looks real, but it's totally static. It's just sitting there. The next step is to make it move. This is the stage I like to call the puppetry. This is where we define all the rules for how objects can move, rotate, and interact with each other inside the virtual world.
The science behind all this movement is called kinematic modeling. Now, the most important thing to get here is that kinematics only cares about describing the motion itself. The position, the rotation, the scale. It's all about the what and the how of the motion. It does not care about why it's happening. We're not worrying about physics like gravity or friction just yet.
And this slide right here lays out that difference perfectly. On one side, you have kinematics, which, again, just describes the motion. On the other side, you have dynamics. Dynamics is the full-blown physics engine that explains why things move. It calculates all the forces, like gravity and torque. For what we're doing here, making things move in a predictable way, we're focused on kinematics, the puppetry of animation. Now, a really key concept for creating believable motion is something called object hierarchies. Just think of it like a parent-child system. It's simple. When a parent object moves, all of its children move right along with it. The robot arm is the perfect example. The shoulder is the parent. If you move the shoulder, the whole arm moves, right? The elbow is a child of the shoulder, and the hand is a child of the elbow. This system creates logical, connected movements automatically. It's incredibly efficient. We've built it, we've painted it, and we've made it move. We're so close. There's just one last step. How do we actually see it? Because even though the world we built is 3D, your VR headset has two little 2D screens. The final process is all about converting that rich 3D world into an image we can actually look at, and it all happens through a virtual camera.
So your view inside VR is decided by three key things. First, the camera's position. That's where your virtual eyes are located in the world. Second, its orientation, which is the direction you're looking. This, of course, changes instantly as you turn your head. And finally, there's projection, which is the really clever math that translates that 3D scene into the flat 2D image you see on your screens. And the method that's used pretty much everywhere is called perspective projection. It's a really simple but powerful idea. Things that are closer to you look bigger, and things that are farther away look smaller. This is exactly how our own eyes work, and it's absolutely crucial for creating that illusion of depth and making a virtual world feel real and immersive. It's the secret sauce.
So there you have it, from a simple blueprint to a sculpted shape to a painted, moving object, and finally, projected into your eyes. Those are the fundamental building blocks of pretty much any virtual world. Now that you know the basics of how it's done, it really makes you think, doesn't it? If you had all the tools to build anything you wanted in VR, what would you create first? Where would you even start?